Okay, so quiz 3, final quiz of the semester. Basically, it's like the final exam because in a way, all of these quizzes have been cumulative. Of course, it's open book, open notes, open on course page. So it's just bringing your best work to the table. One thing I just wanted to point out, I was looking at how I wrote the quiz, and I combined a lot of questions kind of into categories. So just one thing I would want to point out is please just make sure that you answer all the sub questions like within it. So I feel like the format's just a little bit different than the other quizzes in that it's kind of in categories, but I kind of bunched the questions together. So, just make sure you're answering kind of all the questions, and I would just go back over your work and just double check, because sometimes you can get so invested in like answering the first part that you forgot about it by the time you get to like the third question of the section. So that's just one general thing. Another thing is one of the questions talks about standard deviation. And I wanted to talk a little bit about standard deviation because this was something that you guys did in your assignment too. And while the answers were acceptable, I thought some people's interpretations of standard deviation were a little bit vague. So just two things I want you to keep in mind when you're answering the standard deviation question in the quiz is that one thing that's great about standard deviation, of course, it's a way to look at how the different values of our variable, how they vary around the mean. But also remember that it's in the same level of measurement. It's the same measurement as that variable. So for example, I was doing an example of abortion ratios, I think. So it was actually the number of the standard deviation could be equated to that number of abortions. So for instance, if you're talking about a 7-point scale, like 1 to 7, and the standard deviation is 2, that would mean like 2 points on that 7-point scale. So that's one thing to keep in mind when you're interpreting it, is that you could actually like use the language of that actual variable when you're thinking through it in your head and talking about it. So that's one thing. Another thing is to remember the relationship between the standard deviation and the normal distribution. So if your data is normally distributed, and of course that's an if that's the case, then 95% of your observations would fall within 2 standard deviations of the mean. So it's like plus or minus that standard deviation twice. 65% would fall within 1 standard deviation of the mean. So another thing to think about is, okay, you have your mean and you're looking at it in terms of like adding and subtracting that standard deviation. And if that's taking you outside of the range of that variable, so say like outside the range of that 7-point scale, then your data is skewed as well, right? So that's gonna be assigned to you. Oh, hey, this variable is not normally distributed. It's skewed to the right side or skewed to the left side, depending on kind of which addition or subtraction, which of that kind of takes you outside of your scale. So again, just 2 things I wanted to point out about standard deviation. Okay, so I thought another thing is I think you've been doing a good job recognizing sample bias. So when we're trying to think through whether there's a potential for sample bias, one thing to think about is how has the sample been distributed? And that I think has been something you guys have done a good job on your quizzes so far. So I'm not seeing a big problem there, but kind of thinking about were they randomly distributed? How did people opt in or opt out? And then sometimes when we have information about the sample, you guys have done a good job looking at, okay, this group seems to be over sampled, not. Just another thing I wanted to point out, something to think about when we're looking at our samples, is also to think about the response rate. So when we talk about our sampling design, we think about, okay, how do we choose who to incorporate? But then the second half is that, that's basically just the people we choose to send the survey out to at some point. But then it's like, who actually responds to the survey? And are there characteristics in the group of people who choose to respond that in some way make them significantly different than those people who didn't respond? So while thinking about the sampling design is very important, I also urge you to think about not just the response rate, but how the people who choose to respond might be different than the people who choose not to respond. Does that make sense? Okay. So the next thing I just wanted to briefly talk about was, of course, a big part of the quiz is interpreting the regression models. So first I wanted to point out, if my video on interpreting the regression table in the article, if you didn't find that super illuminating, I put another video of another professor explaining basically the same thing, but sometimes it helps to hear it another way. So that's on our on-course page. I think it's just probably about a 7-minute video. So if you kind of want another example of interpreting a regression table, I thought it was really well done. So I put that on our on-course page. Just, of course, in terms of the basics, we know that we're going to read the rows across. The rows are representing the effect of those different variables. And then the columns are basically the different models. So one thing I talked about in my last video is why would you have more than one column? And I just want to point out that you can have more than one model for a number of different reasons. And those are, of course, decided by the researcher. And that's kind of based on their theory. So you could have a situation where they want to have different models because they're breaking up their sample into different groups for some theoretical reason. So that's why you might have more than one model. You might have a situation where there's different measures of the dependent variable. I know in your own project, some of you have this type of example where you have multiple measures of your dependent variable, but you can only have one dependent variable per model. So that might be another reason. And then a third reason that we sometimes see is you want to run models with some of your independent variables and maybe not others to kind of be able to potentially compare across models in some way. So those are all, they're all like theoretical decisions by the researchers. Sometimes it might be hard to kind of determine what's going on just looking at the table, but it should be described to you in the article as well. So I just recommend kind of going back and forth from the article to the table. And when they're talking about something in the article, see if you can find where you would reference that at the table. So don't think that you just need to read the table just completely on its own. Like be going back to, okay, what are they telling me they're doing? Where do I see it in the table? And hopefully that will help. And all right, you guys raise your hand if any questions are arising as I'm talking, please, or just jump in. Just one more thing I wanted to point out was the difference. Why would we want to have beta coefficients and standardized betas, and what's the difference between the two? So first, the regular beta coefficient, that is, again, what we refer to as the slope of the line. It's showing you the change in your dependent variable given a 1-unit change in your independent variable. So that's really a way that you're going to see magnitude, the size of the effect of how much does your independent variable affect your dependent variable. And with that language, like a 1 unit change, it's based on that 1 unit of your independent variable. So that could mean jumping from, you know, a 1 to a 2 on a 7-point scale, or that could look like, you know, $1 in GDP. So again, it's in the units of the independent variable. So really, it could allow you to kind of talk in a concrete way about the size of the effect. Remember, though, we're not going to take that we're not going to really take that beta to heart unless we found that the relationship is statistically significant. If it's not statistically significant, that means that basically 0 could fall within the confidence interval. So we're not at all confident that there's really any effect in any direction. So we're really only going to interpret our significant betas. Okay, so the difference between the regular beta, which we typically would see represented in articles, and the standardized beta, is that with the standardized beta, what the author has done has put them all on the same scale. So it's really just a way where all of our variables are going to be measured differently. As you guys know, we're going to have these 7-point scales, and we might have ratio level in dollars. So it would all be very different how we're interpreting those betas. When they standardize them, they just put them on a universal scale. And the whole point of that is just so you can compare them in a more easy way to see what's having a larger effect compared to another. Because there could be a situation, you know, in my example with the GDP versus the 7-point scale, we'd expect that the beta for the GDP would be much larger, because, you know, just $1 more on a scale like that, or something like population, it would be you know, just be much more likely to have a larger effect, because it's representing, given that 1 unit change. No, the opposite. It would be, much smaller, because that would be such a small change, just adding like $1. Well, versus jumping like a whole point on a scale would be a big deal. Also, like in terms of, if we're thinking about it in terms of dichotomous variables, say we were just, representing race on just on a binary measure, like white or non-white, for the purposes of this example. So it would represent, you know, a change from being white to being non-white. That's what that beta would represent. So that, you know, that would be the whole measure. But anyway, I'm getting a little off topic, but just my point is, betas allow us to speak to the size in terms of how that variable is measured. Standardized betas allow us to compare and say, okay, which of these variables is having a larger effect on our dependent variable. And then the last thing I just wanted to mention again was that R-squared statistic. Usually in articles, you can find the R-squared towards the very bottom of the table. And this is explaining the explained variation in your model. So how much of your dependent variable is being explained by your independent variable? I mean, by your independent variables. So when we thought about it in the bivariate regression example, it's kind of looking at, in terms of when you draw your best fit of your line, how well does that do in minimizing the distance between your various data points? So to think about it kind of conceptually in terms of multivariate regression, there's going to be a whole lot of lines. That kind of gives me a headache. But the way to think about it is kind of like, how much of the variation are you explaining? And when you're thinking about that, be thinking about kind of what variables are in the model. So there might be an example of, say, a model where it's like a time series design and you're looking at change over time. And sometimes the researchers will put kind of T-1 you'll see in the model. So it's kind of like they're putting the data from the year before in the model. So they might have a very high R squared, but a lot of it is just being kind of encompassed by that one variable. So it's just kind of interesting to think about. In political science, usually we'll see pretty low R squareds, like it's 20s, 30s, because we're talking about very complicated topics in which a lot of the variation will go unexplained. But I think the simplest way to think about improving your R squared, meaning you want to see a number, closer to 1, a higher R squared, is to think about, okay, what independent variables might be missing in the model? What could I control for that would increase the amount of variation that I can explain? So it's all just about a conversation about trying to explain as much as you can about the dependent variable. And if you see, models, competing models in which some have more independent variables than others, and you can think about, okay, by adding those control variables, what did that do to the R squared? Did it help me explain more about the dependent variable, or did it not really have an effect? So those are the kind of conversations you want to be having in your mind when you're interpreting the R squared. Okay, that's all I wanted to point out. Um, any specific questions or things you'd like me to go over?
I have a question
Mhm.
about the multivariate analysis. And in the PowerPoint, it says that it can be explored in two ways, either OLS or logistic regression. I just wanted to know, for OLS, is that only applicable to interval or ratio level, or do some researchers use an OLS even if their levels of measurement are ordinal, for example?
Like an ordinal scale?
Yes, yes.
Yeah. Oh, yeah. Very good question, Janai. So yes, you can use an OLS model if your dependent variable is an interval scale. When we're talking about OLS, we're talking about using a model that represents a line. So if you think about a scale being a continuum and kind of graphing your data in that way, it still makes sense that you can use OLS um, for ordinal scales as well. So it's okay for ordinal scales, interval level, and of course, ratio level. The other type of regression, logistic regression, that's what you would use if your dependent variable was something that was what we would call a dichotomous variable. So it's kind of like an either or option. So if I was doing like a model where it was like voted, did not vote, that would be a logistic model. If I was doing like I study the courts, if it was like join the majority opinion, did not join the majority opinion, that would be a logistic model, because we wouldn't, if we tracked our data, you would imagine it would just kind of look like dots all clustered, like here and all clustered here. You couldn't represent that as a line. So when you're talking about the choice to use multivariate linear regression, it's based off of the level of measurement of your dependent variable. And if it's ordinal, interval, or ratio, you can go ahead with linear. If it's not, if it's categorical and dichotomous, then you're gonna choose logistic regression.
Okay, thank you.
Oh, and just one more thing I want to point out is that the other reason why we spend so much time on regression is that regression allows us to include multiple independent variables in the model. So there's a lot of like other interesting statistical tests we can use, but most of them only allow us to look at the relationship between one independent variable and the dependent variable at one time. And so what's so appealing for political scientists with regression is that we can include multiple variables at once. And that, of course, is what's, when we say controlling for spurious factors, what we mean is we hold them constant in the regression model so that we can look at the effect of one variable at a time. And that's what allows us to begin to speak to a causal relationship between variables rather than just a correlation. Any other thoughts or questions?
Yeah, I actually had a question, sort of about how to read the tables. I looked at both the videos, but I'm still like a little confused as far as um the I forget what you call it, but when they have the stars
Yeah,
and how that sort of determines this significance. I was wondering if you could kind of go over that and explain that again.
sure. Um, Right. So what we're talking about is statistical significance, and that kind of goes back all the way back to when we're talking about hypothesis testing and whether we should, accept or reject the null hypothesis. So the place that you start is you need your test statistic for the model. So they don't show us this in the tables, but what it is the beta coefficient, so that's what we've been talking about, divided by the standard error, that's usually right underneath in parentheses. And then that gives you what is the test statistic, and they're not reporting that, but whether that test statistic reaches a statistically significant level is based off the distribution, which we talked about, like the normal distribution before. It's either this z-score or the t-statistic. So kind of all of that in terms of an article, it's all done behind the scenes. And what they're just reporting is the significance level. So that p-value, that's based on the value of the test statistic, which is just the beta divided by the standard error. And the size of it determines whether it's significant or not. So how we would interpret it is that if you see a p-value of 0.05, that means that you're 95% confident based off, the calculations of that distribution. You're 95% confident that the relationship hasn't occurred by chance. So you're saying, you feel confident enough that you can reject the null hypothesis. So, that's kind of just the standard determined by political science that we say, like, we feel kind of okay with 95% confidence. So that's just kind of a decision that's been made. And that's kind of the usual cutoff for statistical significance. It's not, you have to look though, sometimes always check the bottom of charts. Sometimes people will report statistical significance with a 0.1 p-value. That would be interpreted to be your 90% confident. But usually you'll see 0.05, which translates to 95% confident, 0.01, 99% confident, and then 0.001, 99.9% confident is how you would interpret that. Is that what you were thinking about, Jakai, or does that help?
Yeah, yeah, no, that helped. I had one more question. Could you also explain R squared?
Yes. So yeah, R squared, that's the one that is talking about how much of your dependent variable is being explained by your independent variable. So when we think about it, just with two variables to keep it more simple, what we think about is we have our data plotted on our X and Y axis with each of the dots kind of representing where each unit falls on those two variables. What the regression model does is try to draw a line that best fits that data. So you can imagine an example where that line is drawn and wow, like all the data points are practically on that line. But you can see one where if the data is all scattered, even with kind of like trying to draw the line the best, there's still a lot of distance between various points in the line. And really what the R-squared is doing is looking at those distances between kind of what the regression line would predict would be the values of the dependent variable based on different values of the independent variable and what actually occurs. So it's really, we can think of it as kind of a goodness of fit measure between the data and the regression model, basically. And so you can say, like, if you see an R-squared of, say, 0.22, how I could say that 22% of the variation in my dependent variable, so the differences in my dependent variable, are being explained by my independent variables. Does that make sense?
Mm.
Yeah, so the higher the R-squared, the better job your data is doing, meaning your independent variables are doing explaining your dependent variable. So it's kind of, it's kind of like a goodness of fit for the entire model. Any other questions? Okay. And I'm not sure if I haven't already done so. I had another good video like about statistical significance that I can add to our on-course page just to kind of hear it in other language too, if that'd be helpful to explain like the p-values and that as well.
I had another question, one more question.
Sure.
About interpreting the mean. Do I look at the distribution to see how it's skewed? Is that what you're looking for in that question?
Well, you know, our mean, of course, is just like what's the average response. And so, I mean, I think what I would like to see you do is talk about it in terms of the actual variable. So for instance, if I was looking at a 1 to 7 point scale where like 1 was extremely conservative and 7 was extremely liberal, and say I did a survey on Wheaton's campus and the mean is, you know, 5.5, I would say, oh wow, well the mean is 5.5, so it definitely seems like the campus is leaning very liberal, leaning more liberal, because, you know, if they were right in the middle, it would be more like a mean like 3.5. So just kind of like interpreting it in terms of what the researcher told you that they're measuring. Does that make sense?
Yes. Yes, thank you.
All right. Anything else, guys? All right. I think I'll close there for today. And if anything else arises, just post it to the forum. I'll answer more questions on the forum until up until noon tomorrow. And then just post your quizzes, please, anytime. I don't know, anytime before I wake up on Saturday. So yeah, anytime before Saturday morning, please. All right. Thank you, guys. Hang in there. I'll talk to you soon.
Thank you.
Thank you.
Thanks.